Hello and welcome. My name is Norman Clark. I'm the Tech Support Manager, Electro Industries Gauge Tech, and today I will be demonstrating how to set up MV90 records for Nexus 1500, 1450, Shark 270, and if we have time, a Shark 200. So here we go. The first thing you'll notice on my screen on my desktop are or three actually items or programs running. On the far left, it's XICOM. These are where the calls are going out on the ports, 21 ports on this one. You can set that up to as many ports as you want. I really don't know a limitation. Memory is pretty much the limitation. And then you have on the right, you have the MV90 monitor, which is equivalent to a dashboard, what people talk about so much today, basically where all your tasks are executed from or initiated. And then behind that, we have communicator PQA. So these are the three pieces that we pretty much will need in order to get this going. So the first thing we will have to do is connect to a Nexus, or I should say, let's go with a Shark 270, and let's take a look at that meter. The IP address is 192.168.1.11. This is a Shark 270. I have two of them on my rack, and we'll connect to that meter. So once the status screen, a device status screen pops up, we just click OK. It's a Shark 270, and we'll go into the profile. And I'm sure you're very familiar with the profile settings for all our meters. In this area, as you do all your CTPT programming and communications, if you're doing external communications or anything like that, DNP. What we're going to focus on for our application is the trending profile down here. And this is where we'll set up the logs. So this meter has 6 logs that you can write or record information in. And MV90 primarily focuses log 1 or log 2. So we'll focus on log 1. And let's clear this for now, and let's select the region or the points that we want to retrieve data from. So we'll select energy. We'll choose scale energy in the interval, and then we'll click add here for scale energy interval, 1 hours delivered, and we'll do watt hours received. Let's do 4 function meter type. var hours delivered and var hours received. The meter's gonna these are the 4 channels that MV90 gonna look at. Scaled energy delivered, watt hours delivered, watt hours received, var hours delivered, var hours received, and it's going to be recording in 5-minute intervals. So we'll set up a meter for that. The other thing that's important to MV90 is the system settings, is the name. So right now, this is basically part of the serial number as the meter designation. That's also the MV90 device ID field. So it's very important when you're setting up a record. So you need that, and you need historical log information. You also need, obviously, the interval size, and that has to match the method of how you're bringing in data in MV90. So the demand averaging has to agree with what we're recording in the intervals for 5-minute logging. Okay, so at this point we can update the device, and again, the quantities that we're going to be bringing in. So historical log 1 is what we're going to be retrieving data from. Let's give this a name. So let's go up a little bit. System settings. And we'll call it Shark 270. Let's call it test. Okay, and so we'll update this meter, and um, let's let's go ahead with this program. Issues found with the screens, upload anyway, yes. And then we'll just continue. It prompts us to save or download historical log 1, and I will say no in this case because it's all test data. And it says, would you like to upload a time of use profile? Not interested in time of use, so I'll say no, and it'll proceed with the update. After the update has been completed, you'll see programmable settings updated. So we'll click on that. We could go back to just confirm. These are what we're going to be setting up in MV90. We have 4 channels, 5-minute intervals, and the name of the record is going to be system settings. I'll put it Shark 270 test. Hopefully I don't already have a Shark 270 test. So we can exit here at this point, and we could disconnect and just minimize this, and let's go into setting up the record. Setting up a record entails creating a master file. That's when we're talking about the master file. That's what we really need. We can access the master file from the shortcut here, or you can access it from the database drop down here. So either one works. So if you click on that, that will launch the master file page. And here we get a blank page. So what we can do is we're going to create a new customer, and we're going to call it Shark 270 test. Let's see. And that so happens to be the same ID that we have in the system, I should say in the meter, and that wrote it automatically, which is Shark 270 test in the new device field. There are going to be 4 channels we created, so we add up to 4 channels. We could start writing in what the meter ID is for these, which is basically channel information. So I could say KWH delivered, KWH received, KVARH delivered, and KVARH received. Okay, and that'll be our 4 channels. Then we'll click proceed and say okay, and these are what now you could type in name, customer information, and so on, things like that. That's fine. You don't have to do that right now. We can just click next. So when you get to this page, you have the recorder, more, com, all these different tabs here. So we're at the recorder tab. You could give it an ID. We call it a test as a group. You give it a location. The device ID is an important thing in this page. 4 intervals an hour. It's really 15 minutes per interval. When we programmed it for 5-minute intervals. So that would be 12 intervals per hour. You see it says no retrieval. What we'll do is return that answer on. We'll click on the more tab, and we'll select the TIM. This is a Shark 270, so we'll click on our search box for all our TIMs established. So I'll find a Shark 270 TIM, which is TIM underscore SK27. I'll select it. Comes up as TIM number 3. The meter follows DST. That has to be checked if the meter is set to follow DST or it's on DST currently. The other thing is, if you want the meter to do auto time sets and things like that, you would set that there. You would check it here in case if it's auto tolerance. We have parent child. You could set this up for master slave. Previously it was master slave arrangement. They now referred as parent child to be politically correct, I think. So if we had a series of other meters, you would use that, and you would set the meters, whether it's a parent or child, or through a parent or line sharing. So those are different options. In this case, we have no parent-child arrangement. The TIM config file for Shark 270 I have located in the MV90 XI folder under master folder. So this is, I have a Shark 270 TIM here. And if I just take a quick look at what's in the 270, it's basically the TCP equals 1. I have no events, meaning I don't want any events to come in. And because that speeds up the whole call, the process, these are timeout settings. So I'm commenting out those because I'm going to have a system, because I'm connected to a meter directly next to me on an IP or network switch. It's going to default to the fastest, or I should say the default settings, which are basically 100 and I think 100. I'm not sure for ITO, but anyway, no change need to be made there. So we'll select Shark 270 and we'll go on the next tab. And as we see down here, these are standalone. In an advanced course, I would go through what all of this is. You can use the meter for as a redundant metering application if you have two meters wired in the same series parallel arrangement, and one meter would serve as a check meter. In this particular case, it's a standalone setting. The battery install and battery date information, that's just a setting that if you know the date the battery was installed and you have a certain number of dates, you would get a triggered a triggered event flagged for a battery it needs to be replaced. That's for people basically are using gas meters or things like that where they need to have the battery replaced. That doesn't really apply for electric meters. So let's click on the next tab. Here is where you enter in. It says phone number MV90. That's the IP address. So we'll put in the IP address of the meter, 192.168.1.11. And if I click expand here, it's basically it allows me to put more characters, 192.168.1.11, and I'll put my port number in here at 502. This was something added over the years. Initially, it was just one field that you could enter in all of the information, and they just expanded that to a separate field for IP port. Then you have the phone password, 1 and 2, reader password. And what I would do, strongly recommend looking through the app notes for any new meter that you're putting on the system to determine, which would help you determine what you would enter into these fields. If you left this blank here, the unit address field, it will default to address 1, and that's really that's very important when we want to look at the logs. So we're looking at log 1. That's going to be if we're retrieving data from log 1, that would be 1, and we could enter 0, 1, or we could leave it blank. Now, if we decided we go with log 2, we would have to enter in log 2 in the unit address field. So in this case, we chose log 1. So the next thing in setting up the record, usually we set this as 9600, but that's typically for dial-up type applications where baud rate's important, or if we're going over a serial connection. But if we're going over IP, it's irrelevant. The next tab that we have here, down here, we have connection type. So remember we saw connection type in my XICOM stations at IP. So I'm using connection port IP. Now if I'd set up another connection port for, if this was going over a dial-up, or let's say serial, I would have to program in one of my ports here to be a serial port. But in this case, these are all IPs. So we set IP. These are for special Itron meters for cellular network application. That does not apply to us. The plugging area is if you want auto plugging for missing data to take place, and also redundant checks. So if you're doing redundant checking with another meter, you're wired series parallel or a different circuit, but you want to compare the two, or if you want to check the meter can check itself, you could set that up for redundant checking. And routing and route sequence voltage does not apply to us here. Input relays does not apply, and supplementary master file does not apply. So basically what we care about is recorder, more tab, the com, and again, if you're doing redundant checks and you're doing automatic plugging for missing data or issues that you have with data, you have the system for automatic plugging. I generally leave this off. And so we're good to go here. So we click next here, and now we're going to go through the meter channels. So this meter is set up for 4 channels. It's also programmed. If I went back to the meter and let's see if I connect to the meter and I looked at the profile just to confirm, this meter is programmed for kilowatt hours. Okay, and I could look at the energy scaling, and I could see the meters programmed for kilowatt hours. So MV90 by default is kilowatt hour unit of measure. What we need to do is set this up for KW. Unit of measure code is 1 as we set for channel 1, and the multiplier corresponds to the unit measure. So if we say the multiplier is 1 is kWh, the pulse multiplier is 1. Since we're bringing all scaled energy values in, you would set that up for 1. So set number really applies to when you're doing kVA analysis, where you're netting the units, if it's plus and minus, and you're running kVA analysis for what hours delivered, what hours received, VARs delivered, VARs received. So it doesn't apply here. Register type is important if you're doing just scaled energy, but scaled energy interval, you'll have to set this to visual or none, or blank or none. So this is the first channel. Multiply is set for 1. Channels are set for there. This meter also does transformer loss compensation. MV90, I should say, does do TLC type calculations. And in this case, we're not looking at that. When we talk about standard checks, we look at tolerance for validation. So if you want the meter to be within a certain tolerance percentage, 0.1%, I like to set, and I generally like to use a dual method. But there are different methods for performing tolerance check: multiplier method, percent method. Utilities use these according to what they're accustomed to do, basically looking at one of these methods. I like to be out somewhere on the fringe, and I like to check everything really thoroughly. I look dual method, which is check for pulse percentage, I should say, first, and then check for a 30-day tolerance setting. So P then Q. So those are what I choose. If this meter was checking against, we had many more channels. MV90 supports up to, I think, 16 channels. You can have channel 1 check against channel 8, channel 2 versus 9, and so on. And you would do this redundant checking against each channel. That's another form of validating your registers versus your profile information. So let's click next. So I've just gone to channel 2. Here it comes up, visual reading the same. It's going to be kWh received. I've already labeled that, and my multipliers carry over. Once I make the entry in the first page, it will carry all that information over. So this is multipliers are good, the channels are good, and its kWh value, unit of measure code, is 1. So I'll hit next. And here we're at channel 3. We're looking at kVARs delivered. That's the part of the labeling I did earlier when I created the record. So we'll select unit measure 3 for VARs. Nothing else needs to be changed. Multiply again carries over, all your standard checks. So all of these are coming over 0.1% tolerance. So let's go to channel 4 now, and this is channel 4. And if you look again here, 1 is a multiplier. Again, that's kW because it's tied to the register constant measure, unit of measure code. And then we have kvar H as well for channel 4. That's the unit of measure 4, and so on. Everything else remains unchanged. We click next. Okay, and it completes the setup of the record.